Our second soil formation factor is climate. It's very influential, primarily through, what are the two things that are defined for climate? Well, temperature and precipitation. Climate affects soil from the very beginning, driving physical and chemical weathering of rock, and continues to shape soil development long after that initial stage of formation. Let's look at how temperature impacts soil. Well, the higher temperatures means that chemical reactions are going to happen faster in the soil. So soils in warm tropical regions develop much more rapidly than those in cold tundras. While then warmth promotes vegetation growth, which ultimately that's going to add organic matter to the soil, right? Well, the other side of that coin is, well, the organic matter also decays quicker in warm temperatures. This often means that in warm climates, the soils tend to be lower in organic matter because it breaks down quicker than it can be replaced. Another aspect of, say, like a warm and humid region is that the warm temperatures help the soluble materials in the soil actually become dissolved in the soil solution. And then as that water percolates or flows through the soil, it leaches quicker. So warm and humid climates equals faster dissolution and more leaching. Okay, and then there's precipitation or rainfall. What is water's role? Well, water's absolutely critical for soil genesis. It's involved in most chemical weathering reactions like hydrolysis and hydration. In cold regions, it's essential for frost wedging, right? Well, water also moves materials. Water moving down through the soil leaches dissolved minerals, and it can even translocate, aka move, fine soil particles like clay. Now, climate does affect soil characteristics. As a general rule, soils in moist climates tend to be deeper and have more organic matter in the topsoil. Clay particles and salts tend to move deeper because of water pushing them, and the soil generally becomes more acidic. In contrast, desert soils and drier climates tend to be enriched in salts that wouldn't leach out. In the United States, it, it offers a great example of climate's influence. As you move from south to north, the climate cools and you generally see an increase in average organic matter content. Similarly, from west to east, rainfall increases and soil organic matter tends to increase as well. All right, let's talk about the incredibly active and vital role of soil formation organisms, or what soil scientists often refer to as biota. If parent material is the raw ingredient, organisms are the tireless chefs, constantly working to transform that ingredient into rich, living soil. This factor encompasses everything alive in, on, and around the soil. So first, perhaps most visibly, is the vegetation, the plants. Plants are absolutely critical. Their roots penetrate deep in the cracks, aiding in physical weathering. More importantly, when plants die, their leaves, stems, and roots decompose, adding organic matter to the soil. This organic matter is the lifeblood of the soil, providing nutrients, improving structure, and enhancing water retention. Different types of vegetation like forests versus grasslands will create vastly different soil profiles because of how they can contribute organic matter and cycle nutrients. Now next are animals, both large and small, macro large, micro small. These includes everything from earthworms, moles, gophers, which are our macrofauna, to tiny mites, nematodes, and microfauna. Those are our microfauna. These creatures are nature's excavators and mixers. Earthworms, for example, burrow through the soil, creating channels for air and water, and they ingest soil particles, mixing organic matter with mineral matter. This bioturbation is essential for creating healthy soil structure and moving materials around. So let's take a closer look at vegetation. The type of plants growing on a soil has a particularly strong influence on its properties. We kind of think that the soil dictates the plants. Well, the plants also help influence the soil. So you think, consider a difference. Under grasslands like prairies, the vegetation, mostly herbaceous, forms deep, dense mats of fibrous roots. A large amount of these roots die each year, contributing significant organic matter deep in the soil. This results in high organic matter content in dark colored soils. In a forest, much of the plant biomass is above ground in the trees. When leaves fall, they create a surface layer of organic matter that doesn't mix as deeply with the mineral layers. So forest soils generally have less organic matter, they're shallower, lighter colored than prairie soils. Types of trees matter too. Conifers, their foliage tends to create more acidic soils, and the organic matter decays much slower, leading to thinner, more acidic soils. With sparse vegetation, desert soils have the least organic matter. And you think about it, plants don't grow fast, and the high temperatures cause that organic matter to break down quick. Plants also play a vital role in nutrient cycling. They absorb, the ions from deep in the soil and bring them up to their tops, the nutrients. When leaves drop, these ions return to the soil surface, reducing their loss from leaching. Building on our last discussion there from the last slide about the organisms factor in soil formation, let's put this in a broader context. This map illustrates the native vegetation of the United States, showing the types of plant communities that naturally thrive in different regions before us altered everything, right? So why is this map important for understanding soils? Because vegetation is a primary driver of the organism's factor. Different plant types have profound different impacts on the soil beneath them. If you look in the east, you got these large expanses of forests. And in temperate regions, they tend to accumulate organic matter primarily on the surface, their leaf litter. And they have extensive root systems that can tap into deeper soil layers. The decomposition of the tree leaves often lead to soils that are slightly more acidic, right? That makes sense. That's how they are around here. And develop distinctive organic and topsoil horizons or layers. Now, if you go to the plains, right, they're dominated by grasslands, at least historically. These soils are famous for being incredibly rich and fertile. Why? Well, like we said before, grasses have dense fibrous root system that dyes and replenishes the organic matter throughout the topsoil every year. This constant input of organic material distributes deep in the soil by those fine roots leads to the development of a very thick, dark, and highly productive topsoil. Then if you go out here in the west, especially in the southwest, it's arid, semi-arid regions. You see desert shrubs and sparse vegetation. In these areas, there's much less plant growth, which means less organic matter is added to the soil. As a result, these soils are often light in color, shallower, and have less developed horizons or layers compared to forest or grassland soils. If you traveled to Arizona last year, think about the color of the soils out there. Most of them were all light colored. So just to hit on a couple points related to that map, what it's shown us is how the type of vegetation directly influences key soil properties. For organic matter content, grasslands typically lead in higher organic matter. For nutrient cycling, different plants take up and release nutrients differently. So they're altering the chemical properties of the soil depending on what plants are there. And then root systems create pathways and help aggregate soil particles and create soil structure. And finally, the vegetation cover protects the soil surface, helps slow the water and help it soak in and infiltrate into the soil. This intimate relationship between native plants and soil explains a lot about the natural fertility and characteristics of soils across all of our diverse landscapes. Now, before moving on, let's pause. Let's review with some questions.